All right, let's talk about a few other things in here that we always see. Um, but let's talk about, angular resolution, um, light diffraction, light reflection, um, looming and magnification. Um, all of these things, and probably some other effects, are all taking place within this. So, we watch these things, and, I'm looking at this kind of like a sliver of water going out. And progressively, the farther out you go, the more area is in the little sliver, like way out toward the edge. Every little increment there, every little eighth of an inch is miles. And then, progressively coming back towards me, it gets to where it's less and less and less distance. In other words, where I see some of these boats, they are, 3 miles when they're, or 3.5 miles when they're right out there by the Bayport bird rack. But you can see water well beyond that. And that's that area right there that I'm talking about is actually miles and miles and miles in between, from there to the visible water line. And then you have this mirroring effect that also plays a role in causing the appearance of things appearing to sink. But also downward refraction is probably a good way to put it. But like this sign that I'm looking at, this is a sign. I thought it was a boat, but it's actually a sign way out in the water. Now that sign was getting pulled down, but it was also being compressed and stretched. In other words, it's being compressed downward but stretched out at the sides. Same way with that boat in one of my, I think it was the last video, where the boat looked long and skinny. That boat was probably much shorter, but because of the compression going on out there, it causes the illusion that that boat is long and skinny. So, we also have, the light reflecting off of the water and the angle that that light is coming into the water, and the angle that it's coming in to my camera or into my eyes as I, draw closer and closer to where the sun's at. Then I start seeing the flickering water, glistening water, glistening, glistening. Yeah, it glistens. And it also shows you that it is reflecting. So if we got a reflection going on, well, if I am right, which I think I am, anything past that visible water line, I mean, you can see this little sliver just above that water line. It's like an aura. And that right there is more water. But it's on such an angle that it creates this mirage or this mirroring effect, because that's what creates mirages out on roads. You've got your angle of resolution causing the miraging or the mirroring, and that's the same thing that's going on here. And some days is worse than others, and as I progress through this day, as the sun gets farther from me and creates another angle, some of this stuff that I'm looking at all of a sudden gets drawn down into the mirror, and it actually does get cut off. It gives you a visual cutoff. So if you was to take the first video that I did this day and compare it to one of the last ones, you'll see how everything changes. Everything gets dragged down, dragged. It's not being reflected upward or being drawn upward. I mean, look at this water, the way it glistens. I mean, you can see it out there. So imagine, because of my angular resolution, and this boat's not going to fall off the edge anytime soon. He would just continue to go out and get smaller and smaller and smaller, just like a lot of these boats do. And then they get so far out that you cannot resolve, the camera cannot resolve that edge. And also there's, like I say, there's water there that you cannot see. It's like invisible water because it's in the mirror. And there's waves in that water, and those waves are non-detectable. They're invisible. You cannot see them because of that angular resolution, and that is what actually cuts off boats as well. So there's multiple causes to this stuff. Now watch that little boat out there. He's way out there, and I was laughing because this big boat goes by and makes him look like this little tiny little thing. And this big boat, I cannot see it with my naked eye, and that's kind of what I was laughing about. I'm looking up over my camera trying to see it, and I don't. Now here's something interesting that I want to bring to your mind, to focus, is look at this pole right here. Look how the water or that light is being diffracted around it, and it causes the illusion that the pole is bigger than really what it is. And that's partially because of focus. Now, if I was to focus in on it, it would look like a pole again. But because I'm not focused on it, I'm focused out further, I get this light diffracting around that pole. And you can literally see water in there. It's pretty cool when you look at it this way. And that's kind of turn that sideways, and that's the same thing that also occurs out there. You get this light diffraction that blocks out things or creates the illusion of it being cut off. It's all about angle, focus. Like you get down flat to a table and you look across it. Do it when it's in a dark room, or a fairly dark room with no light on the table, and then turn a light on above that table while you're looking, and watch how your eyes cannot even focus and you get that light diffraction. Now watch this boat. You don't really see the waves or the wake that it's putting out, and then all of a sudden the camera starts resolving that wake. It starts resolving it, and it starts picking it up. Well, why wasn't it picking it up before? Because it was in the mirroring. Beep, beep. I don't know what beeps sometimes, but strange while I'm doing videos. But look at there where he hits a little wave or a wake. And then also, this boat's coming from way out there. These rocks right here are pretty much just before Bayport Bird Rack. So, that right there, that sign is not far from Bayport Bird Rack. It's just in front of it. As you pass these rocks and that sign, then you're passing, a little bit further up, you'll pass the Bird Rack. Now, like I said, I've fished this water for a long time, so I'm very familiar with the location of these rocks and signs and everything. So, as I'm viewing from this angle, and my camera is set not at the highest, it's set low, but this was also a very low tide, and I was not right on the shore. I was up on the land a little bit. I was up on that corner where I usually sit now. I found another spot where I can sit, but I like it because I can use it as a windbreak when it is really windy. Sometimes, depending on which way that wind's blowing, I can use it for a blockage. But now, watch how this boat, how long this boat goes. Now, this boat's probably doing 30 miles an hour on the water. So, if he's doing 30 miles an hour, then if he was doing 60, he would be doing a mile a minute. So now he's doing 2 miles a minute, because you're going to cut that in half, or let me get that straight. He's doing a mile every 2 minutes instead of every 1. And I've been following him for a while. So he was well past Bayport Bird Rack. And you'll see here, either between this one and the next video, I think it's this one, you'll still see it. And then look at this other boat coming in too. They're going out. He's going out. This boat's coming in. Now watch that wake too. Watch how that wake blends into the background, blends into the horizon. And that's, you know, everything's blending. It's the convergence. That's another thing too, where everything converges. The sky and the water converge. That's just that. It's just a convergence. The clouds are on a parallel line from me, from above my head to the ground that I'm standing on. Because I am standing on the ground, low to the water, I see way more of the sky, so it creates this dome effect in a 360 degrees around me. It gives me the impression that I have a dome over my head. Now, is there a dome? I can't say that I know for a fact that it is, because I've never seen it. Just like I've never seen Earth from space spinning, you know, spinning around and chasing the sun. And you know, they say the sun's at the center of the you know, our heliocentric model, but it's flying through the Milky Way galaxy. Funny, huh? So I think we're more or less, we are the center of the universe, and everything's going around us. Not around the ball, around a surface. How big is the surface? How far does it go? I don't know. I've never been to the edge. I don't think that there is an actual edge that you can fall off of. I think it's a continuing plane to a point, to the edge of the container. What holds us all in, just like a coffee cup, a bathtub, a swimming pool, it holds the water in. What's beyond that, I don't know. But just watching this video tells me that angular resolution is playing a big role in how we see miraging, compression, looming, angular resolution, angle of light. All of this is all playing a role. It isn't just one effect. It's multiple effects playing a role at the same time. And this is why we get the appearance of an edge. It's just perspective, because we're at a low perspective to the water. The higher up you go, the farther out you can see. It gives you a different perspective, a different angle, a different angular resolution of that water. You're not seeing over the curvature of Earth like mainstream science wants you to believe. They've never actually showed anything being pulled up from behind a curve. Demonstrate it without using tricks, you know, without using butane over a tank and causing something to be pulled up by a trick. That's not a good way to prove your point. Go out and do it in a natural way. You know, look at something over a little hump, or, you know, set your camera where something goes behind this little hump, and then use light refraction to pull it up. They can't do it. They won't do it. And they'll argue with you and get you off that subject. Challenge them. And and all you'll hear is crickets. Crickets, because they can't do it. Their little monkey brains can't do it, but they believe it. And then they want you to believe it. They get angry and get mad and tell you that you should listen to them and believe their little monkey brain. All right. Thanks a lot. Like, subscribe, and share. Have a good day.